Hello dear student, I am Monur Islam. Welcome to the second lecture of real analysis. Okay, so today previous day we have discussed 5 questions. Okay, and of continuity. Today we will discuss another 5 questions. Okay, and we are going forward day by day. Okay, so without delay, let's start. Okay, this is a question to the left. Okay, so I am starting with this question. So this is a question. I think year is June 2017. Okay, this is a question of CSR. This is a question of CSIRNET June 2017. Okay, this question from part B. Okay, this means it is 3 mark. Okay, of continuity. I will discuss every question of each question of real analysis of continuity. After that, I will go to the question of NVHM, and after that, I will discuss the question of TFR. Okay, I will discuss every question of every year and chapter also. Okay, so don't worry. And keep watching my channel and subscribe my channel and follow my channel regularly. You will get all things here. Okay, so let's start. So this is a question said that P is equal to A alpha square plus B alpha square plus beta plus gamma. Okay, this is a polynomial. Okay, where alpha beta r belongs to real number. Okay, and saying if x is not belongs to r, then the set this set is equal to ABC belongs to third order by r cube such that P is equal to A is not square plus B is not plus C. The number of elements in the set. How many elements in the set? Means it asking the number of elements in the set. Means what is the cardinality of S? Okay, number in the set. Okay, so see, it says that fix x naught. Okay, it says that fix your x naught. So I am fixing my x naught. So I am fixing my x naught to be 0 for convenient. Okay, if I fix x naught to be 0 and 0 is a real number. Okay, so I am fixing my x naught to be 0 so that the problem become easy. Okay, our aim is to solve the problem very easy method. Okay, so that in examination we doesn't fix any confusion. Okay, you have to know the trick to solve the question in few seconds in examination. Okay, so then px become a x normal means a x minus 0 the square plus b x minus 0 plus c. Okay, right, then this gives ax square plus bx plus c. Okay, this is our px. Okay, but here px is given. Okay, this is a px according to set. If px you have to assume let px belongs to the set S, then px of the form this. Okay, if x not 0, x not equal 0. Okay, if x not equal 0, then px be the form of this. But px is given, I mean px is given in this form. So this px should be equal to this px. Okay, so according to the question, so you can say according to the question, according to the question, okay, you can say alpha x square plus beta x plus gamma, this should be equal to, because this is the given px, this is equal to given px, this is the px, this question is given, and my px is this, so this is x square plus bx plus c. Now you get the coefficient. If you equate the coefficient of x square from both sides, you get a equal to alpha. Okay, if you equate the coefficient from both sides of x, then you get b equal to beta. Okay, if you get the coefficient of constant term, then you get c equal to gamma. Okay, now abc, so what will be the order pair abc? Then you can say what will be the order pair abc? This is nothing but alpha, beta and gamma. Okay, now S with the set of all order pair. Okay, S with the set of all order pair ABC belongs to R cube such that px means equal to 0, means px means this px ax not the square plus bx plus c. Okay, I am not writing this. So see, we have ABC equal to alpha beta gamma. So in here, from here you can put alpha beta gamma. Okay, so this set become like this, alpha beta gamma belongs to R cube such that alpha, you can say alpha beta belongs to R. Okay, So you can rewrite this S. You can write the set S. What will be the S? S will be this, or S will be this, alpha beta gamma order pair such that alpha beta belongs to R. Okay, S. Now you can say, see, Px is a polynomial. Is any polynomial. Suppose Px be this polynomial, 2x square plus x plus 1. Here alpha beta gamma is what? Alpha is 2, beta is 2, beta is 1, and beta is 1, and hope you understand gamma is 1. Okay, so this alpha beta gamma is unique, na? So this alpha gamma is unique. So in this case, this alpha beta gamma is also unique. Okay, this alpha beta gamma is unique value. So this set S contains only one element, means only this element. So this set has only one element. So cardinality base will be 1. Okay, so in the question cardinality will be 2. Okay. So its cardinality not 0 because it's 1. Strictly greater than 1, no. It's cardinality 1, infinite to not. So it's cardinality 1. So in this question, cardinals are option 2. Okay, so now let's go to another question. This question. Okay, don't see the mark answer. Okay, we'll verify it. See this question. Because Z denote the set of all integers, and Z greater 0 means Z non-negative integer. Okay, integer with non-negative, and the set 0, 1, 2, 3, so on. Because the map this f from Z not to Z by this. Then asking this whether surjective or injective. Okay, so let's say it is a question of CSIRNET. The question of CSIRNET December 2017. Okay, and part B question means 3 mark question. So let's start. See, the mapping is given this. Okay, let f from Z naught, Z integer, non-negative integer. Okay, to Z given by fmn equal to 2 to the power m to n plus 1. Okay, this you can say mn belongs to Z greater 0 cross Z. Okay, now this is the mapping. So you have to check injectivity and onto-ness. Okay, so onto means this, if this mapping is onto, listen please, if this mapping is onto, if this is onto, okay, then each element of the codomain will have a preimage here. Okay, so see, suppose I am assuming there is m greater 0 non-negative integers. Okay, and n belongs to integers such that if mn equal to 0. Okay, means I am checking that whether its domain is self integer. Okay, so there is 0. So I am assuming that suppose there is a integer, there is a preimage of 0 and it is mn. Okay, so m will be, it belongs to the set Z to non-negative with Z, so m will be belongs to set of non-negative integer, n will be belongs to self integer. Okay, so I am assuming that if there is the order pair mn such that f of n equal 0, means it is a preimage of 0. Okay, mn is just preimage 0. So according to definition, you can write this 2 to m into 2n plus 1. Okay, we all know exponential is always non-zero. Okay, so from here you can get this 2n plus 1 equal to 0. Okay, so this gives you n equal to minus half. But see what happened, what will be the problem? See, n belongs to integer. Okay, it says n belongs to integer, but it says n equal to minus half. It is possible? Never. It gives a contraction. Okay, it gives a contraction because n equal to half is not an integer. Okay, you have to n equal to n belongs to integer, right? But it gives n equal to minus half. It is a rational number, not an integer. So this is contraction. Okay, so you can say 0 has and does not any preimage in the coordinate set Z non-negative cross Z. Okay, 0 have, this 0 have does not have any preimage. Okay, in the domain. Okay, so since 0 has no, 0 is the arbitrary, 0 is an element of the codomain and it has no preimage in the domain. Okay, so you can say this map is not onto. Okay, because if it's onto, then every element of the codomain has at least one preimage, right? Every element of the definition of onto is, if it's onto, then every element of the preimage, every element of the codomain has at least one preimage. Okay, 8 is on image, but in this case 0 has no image, so you can say this map is not onto. So you can say this map f is not onto, means not positive. Okay, so since not onto, so if it's not onto, so it says that both onto one, it will be incorrect. Okay, it says onto, so option will be incorrect. Neither on or onto, so you have to repeat either 2 or 4. Is on or not onto? Neither on or not onto. Okay, so now I have to check the injectivity. So I am checking the injectivity. Okay, so I am going to check the injectivity. Okay, so I am checking here. See, if you check if for the injective or not. Okay, so what is the mapping? F, I am writing through z to z by fmn equal to, you can say 2 to the power m to n plus 1. Okay, mn belongs to z non-negative cross z. Okay, so we check it is ontoness. Okay, we want the definition of onto is if it is onto, so let m1 n1 this order pair and this m2 n2 be two order pair z2 cross z. Okay, such that if m1 n1 equal to if m2 n2. Okay, so if it's onto, then this will imply, if it's onto, then this will imply m1 n1 equal to m2 n2, right? This is onto, then this will imply. Okay, so sorry, if it's on if it's on if it's on means injective. Okay, or you can say on. If it's on, then this implies if n1 equal to if n2, if x equal to fy implies x equal to y. If x equal to fy, this gives x equal to y. Okay, so I am assuming this. Okay, and you have to prove this. So for convenience, I am assuming f of m1 n1 equal to f of m2 n2. So what does gives? Even the definition of f, this gives 2 to the power m1 to n1 plus 1. Okay, and this gives 2 to the power n2 to n2 plus 1. Okay, so this will happen. Okay, I am naming it 1. Now see, so there will be 3 case areas. Okay, I am assuming that this I have to prove this. If m1 n1 equal to m2 n2. Okay, I have to prove this m1 n1, I have to prove this m1 n1 equal to m2. This you have to prove this. Okay, so for contradiction, I am assuming that this is not equal. Okay, not equal, so it will give contradiction. So I then we will get the conclusion that this is equal. Okay, so we are taking contradiction method. So okay, so we are going through contradiction method. So for convenience, we are going contradiction method. So see what we can do. See, so for contradiction, I am assuming that if possible let I am assuming m1 n1 not equal to m2 n2. Okay, and we have this 2 to the power m1 to n1 plus 1 equal to 2 to the power m2 to n2 plus 1. Okay, this I name it 1. Okay, by if m1 equal to fm2 into this gives. Okay, now assuming m1 not equal to m2 n2, so there are 3 cases may be happen. Okay, if it is not equal, then there are 3 cases may be happen. Okay, first of all, this may be happen m1 equal to m2 but n1 not equal to n2. Okay, this may happen, or this case may be happen m1 not equal to m2 but n1 equal to n2, or this case may be happen m1 not equal to m2 but n1 also not equal to n2. Okay, so if it m1 not equal to m2, if it's in this case, okay, if it this case, then from in this case you can write 2 to the power m1 into 2n1 plus 1. This will be, since m1 equal to m2 from here, from above, okay. See, if this case happen, then from 1, what you get, if you will put m equal to m1 equal to m2, so this response will be out. So this gives 2n1 plus 1 equal to 2n2 plus 1, so this gives 2n2 equal to 2n1, this gives n1 equal to n2. But here n1 not equal to n2, so this is a contradiction, okay. So in AI this case never happen. Now going to the next case, you can see this case also gives a similar contradiction. If m1 not equal to n1 equal to n2, okay, m1 not equal to n2 means this n2 should be equal to n1, okay, this n2 should be equal to n1, means if this case happen, then 2 to the power m1 n1 plus 1 m2 not equal to this, 2 to m2 n1 equal to n2, so I am putting m2 equal to n1, so this is supposed to be out. So 2 to the m1 it will be equal to 2 to the m2, okay. You take it log two side, you take a base log with a log with base 2, and gives m1 equal to m2. But see here we have m1 not equal to m2, okay, you have m1 not equal to m2, so this case never happen. Now going to the third case, if you see, assume this case will happen, m1 not equal to m2 and n1 not equal to m2, okay. Assume third case will happen, means m1 not equal to m2 and n1 not equal to m2, okay. And for since m1 not equal to m2 and both are integers, so assume m1 will be greater than m2 without loss of generality. With loss of generality, assume this, okay. So you get 2 to the power m1 2n1 plus 1 and 2 to the power m2 2n2 plus 1, okay. So from here you can write 2 to the power m1 minus m2 into 2n1 plus 1, this gives 2n2 plus 1, okay. Now see m1 greater than m2, so this m1 greater than m2, from here you can tell that m1 minus m2, this expression will be greater than 0, okay. And both are integer, so m1 minus m2 say greater 0, means this is greater 0, so here a 2 will be remain, okay. So since 2 will be remain in this product, so this 2 into this product will be an even number, okay. Hope you understand, this will be even number, okay. But 2 into plus 1, this is the form of odd number, so even number never equal to odd number, so this gives a contradiction, okay. So this gives a contradiction, so this case also not happen. Third case also not happen. So you can say this order pair will be equal. If it is not equal, so then the thickness and thickness give contradiction, so you can say this is not equal will be not happen, means this will be equal happen, m1 n1 will be m2 n2, okay. So since f of m1 equal to f of m2, this imply f of m1 equal to f of m2, for this imply m1 n1 will be m2 n2. So from here you can say f is 1, okay. From here you can say f is 1 or injective, okay. This is the difference of injective. If is equal to fi, if f is equal to fi imply x equal to y, then it is imply injectiveness, so f is injective, okay. So you can say it is injective, so it is 1 on but not on 2, so option 2 is correct, neither on or on 2, no, because it is 1 on, the map is 1 on but not on 2, okay. So in this question correct answer will be 2. Hope you understand, okay. So now we enter third question. This is third question, okay. This is the question, third question. This question came in December 2017, okay. CSIRNET December 2017. This question from part B and it is 3 mark, okay. So see what is the question asked. Which the following is necessarily a function, okay. Which the following is necessary function is, which the following is true for a function f from x to y, okay. There are 4 options given, so we are going to cross check this option, okay, 1 and 2, and after we are going to verify 3 and 4. So first of all cross check this option. If f is injective, then there is mapping g to y to x such that f composes g equal to y, okay. See, I am assuming that 1 is hold, okay. Suppose I am assuming that 1 is true, okay. If 1 is true, then it gives f of gy will be equal to what? F of gy equal to y. This is f of gy equal to y for all y belongs to y. So it will imply f compose g of y will be equal to y for all y belongs to y. Okay, so it gives nothing but f compose g equal to identity mapping on y. Okay, because if identity, this mapping is a mapping from y to y, this identity mapping. Okay, this means iy y will be itself y itself. Okay, this identity mapping. We all know identity mapping is always bijective. Okay, clearly it is bijective mapping. Since identity mapping is always bijective, okay, so this map is on also plus on to also. Okay, means injective, surjective both. We all know if compose is injective, if it injective, then last part is composition, second part will be on first. If it on to, then composition first part will be on to. Okay, you can prove it easily. I am saying that suppose assume for second one, assume if compose G is iy and it is 1 on. Okay, means injective. Okay, so from here it will imply directly that last part, composition last part, means G is 1 on, means G is injective. Okay, you can verify it easily. So suppose for verifiableness you have to check. Suppose gx, you are taking gx equal to, you are taking gy equal to let what is mapping from g is mapping from y to x. Okay, so take two member of y, so take y1 y2, take y and y2 belongs to y such that g of y1 equal to g of y2. Okay, so if it injective, then you have to prove y1 equal to y2, right? You have to prove this. Okay, so g of y and g of y2, now make it composition, take f, apply f both side. If you apply f both side, this f of g1 will be equal to f of gy2. Okay, but f of g1 is nothing but f compose g of y1. Okay, the f compose g of y2. Now f compose is identity mapping, so it will be int y1, f compose int y2. Okay, and it's identity mapping, so it map itself. So it map y1, it map y2 itself. So if g of y1 y2 is imply y1 equal to y2. So this map is imply g is 1 on. This may imply g is 1 on. Okay, so g is 1 on mapping. So if f compose is 1 on, then the last part, you can say last part, this part is 1 on. So from here you can say, since f compose is 1 on, so you can say g is 1 on. Okay, and g is 1 on. If is not 1 on, g is 1 on, but it's saying if is 1 on, means if is injective, so it is not true. Okay, now go to the second option 2. It's saying if is surjective and there y mapping y to x, f compose g of y equal to y. Okay, this also we are going to verify in cross check. If of g equal to y, from similar condition, this gives g f compose is identity mapping. Okay, if of g equal to y, this gives f compose is identity mapping. If identity mapping is bijective, then it is on to also. If you on to, then first part, you can say first part is on to. Okay, means f is on to. This also, you can also prove this. Okay, we see quite similar result. I'm not going to prove this. This is quite similar result. Okay, so f is on to. But here, see, here is saying f is surjective, means f is on to, so it will be correct. So option 2 will be correct answer. Okay, so in part B question type, so only option correct. So you can mark the option B is correct, option 2 is correct, and go to next question. Okay, but don't worry, we are going to verify 3 and 4 also. So verify 3 and 4. It's saying f is injective and y is countable, then x is finite. If it's injective, then y is countable, then x is finite. See, if I take the mapping for 3, option 3, for option 3, it's saying that it is saying that if f is injective and y is countable, if it's injective and y is countable. Okay, if it's injective and y is countable and x is, then x is finite. Okay, so for second reference, I am taking x is natural number. Okay, certain number. So set natural number, y is z. All know certain is countable. This is countable. CT BL. Okay, so countable. And I am taking the mapping this. f from n to z by f of n equal to n. Okay, so no one need to check its ontoness. Okay, because if from n on n to z by f n equal to n on, this is clearly on. Okay, this may be injective. This may injective map, and y is, this is y, means y is z, it is countable, and this is x. Okay, then according to the question, x is finite, but x is natural number, so it is infinite, so it is not correct. Okay, this is one reason. It is the counter example of 3. Now can you give counter example 4? If is surjective and x is uncountable, then y is uncountable infinite. Okay, choose the mapping this. If you choose the mapping f from R to single data set 2, okay, by f of x equal to 2, I am choosing this mapping. Okay, choose this mapping. If from x equal to R, set of real number, to single data set 2, this is Ry, only 2, defined by, I am mapping it also 2, means each element of real number has image 2. Okay, so it image will be equal to codomain, no issue. Okay, it is a constant function, it will be constant function, each it will map 2, so image of f will be nothing but single set 2 and equal to y, so this is on 2, so this is on to map, and it's surjective map. Okay, surjective, and y is x is uncountable, this is R set of real number, it is no need to tell uncountable. Okay, but whether y is countable infinite, it is finite set. Okay, it is finite set y, so it is countable, not countable infinite. Okay, not uncountable infinite. It is saying that it will be uncountable infinite. No, it is countable finite. Okay, only one content. So this option also going to incorrect. So in this question, correct option will be also will be 2. Okay, option 2 will be correct answer. Now going to part C type question. Okay, I discussed 3 questions of part B. Now we will going to discuss the question of part C. Okay, we will discuss 2 questions of part C. See, it says that H any set. Okay, P8 power set. Power set is what is defined? Power set defined here. Power set is the set of all subset of A. Okay, for any set A, power set A is nothing but set of all subset of A. Okay, anything but those B set of all subset. Power set A is nothing but set of all subset of A. Okay, so then which of the following are true? It's asking. Okay, so first of all, don't see the option, that's the answer. Okay, we're going to verify this. Okay. I have taken this question screenshot from the book. Okay, that book has mark. Okay, so don't worry, I am erasing it and we'll go to verify each option on one. Okay, maybe some option wrong. Okay, so PA, this is the power set of A. Okay, the power set of A is the set of all subset of A. Now going to option 1, it says PA equal to 5 for some A. Okay, for some A, PA equal to 5. It said, suppose if A is set, then it contains worst case. I mean, contains worst case. If you say it contains 0 element. Okay, it's the worst case. But if it is set, then it contains at least 1 element, right? Or maybe it contains 0 element, or contain more than 1 element. Okay, so it's worst case that it in the set contains no element, and in this case scenario we denote this set phi, empty set. This set contains no element, empty set. This can set called empty set. So if it empty set, so if you apply the subset theory, means you can say this set phi set also subset of A, because every set subset of every set phi, empty set subset of any set. Okay, so if it phi, then also phi is also subset phi. So power set of, you can say power set of A equal to power set of phi, phi empty set will be this. Okay, means this power set empty set also contain 1 element. Okay, if it empty set, then it power set also contain 1 element. Okay, but if it not empty set contain more than 1 element, assume A contains 1 element, then you will, even the formula of PA, you can write current of PA will be current of 2 to the power A. From here you can say current of 2 power 1 to 2, this contains 2 element. So if it contains 0 element, if the set contains 0 element, means a is 5, then power set contains 1 element. Okay, but it contains more, if it contains one or more than 1 element, then power set contains more than 1 element. Okay, so power set in any case never be empty. Okay, means power set contains at least 1 element. If it empty power set empty set, it also contains 1 element. Hope you see here. Okay, do you understand? If power set if power if A is empty set or contains no element, then power set contains at least 1 element, and this set and this will be going to power set of 5. Okay, this will be going to this element going to power set of 5. But if it contains more than 1 element, the account of formula current of power set away equal to power current away, this gives the this is more than 1 element in power set away. Okay, so in any case power set is not equal to 5, means power set never be empty set. Okay, what will be the set? Okay, so option 1 is incorrect. So hope you understand my point. Okay, are you getting my point? Okay, so now going to option C, option B. It says that pH finite for some A. Okay, pH finite for some A. So it is quite clear. Okay, so pH empty is incorrect. It's saying pH empty for some A. Suppose option 2, for option 2 I am choosing, let A set A contains element, current of A will be n, and assuming A equal to this set is x1 x2 xn. Okay, it contains n element. So we know, what do we know? We know that current of PA will be current of 2 to the power current of A. Okay, now current of A will be n, so since current of A will be n, so you can say this is finite set. Okay, this is finite set, and then current of A PA will be 2 to the power n. This is also a finite number. Okay, this is also going to a finite number, because n is 2, then this will be 2 square 4, n is 3, then this gives n 2 cube means 8, so PA will be also finite. So if n is finite, then power set is also finite. Okay, so you can say option 2 is correct. Now is a pH countable then for some A. Okay, so we know every finite set is countable. Okay, a countable set is either finite or you can say innumerable. Okay, means it does a binomial from that set to natural number set. Okay, so pH countable if it's finite set. Suppose I am taking that this example work also for option 3. So if I take current of an, means A is finite set, so finite set also countable in say is finite, and finiteness implies is countable, because we will all know every finite set is countable. Okay, countability, there are two types. One is countable finite, one is countable infinite. Okay, so if it's finite set, it is countable finite. If it's not something like natural number set, natural countable infinite. Okay, but if it's finite set, it is countable finite. So it is finite set, so it's countable finite. So current of P will be 2 to finite, is also finite. Okay, so you can say finiteness also implies countableness. So from here you can say it PA will be also countable. Okay, so for a countable set we get a power set will be countable. If I take a finite set, then it is every finite set countable, so its power set will be also countable. So in this you can say option 2 is also option 3 is also incorrect. So option 2 is incorrect, option 3 is incorrect, option 2 is correct, option 3 is also correct, and option 1 is incorrect. Now, so till now we have discussed option 1 is incorrect, option 2 is correct, option 3 is correct. Okay, now what will on option 4? What will be option 4? Okay, tell me what will be option 4? Correct or incorrect? So let's verify. If PA is uncountable for some A, it's saying that PA is uncountable, PA may be uncountable for some A. Okay, so there's some example where PA may be uncountable. So see, if I take this, let A equal to natural number, or you can take Q or Z also, any of this. Okay, if you take any of this, we all know this set are countable. Okay, and we all know if a set is countable, then current is alive not, or you can say alive not. These two are notation of alive not. Okay, so now you apply current of this formula. Current of power set A is nothing but current of 2 to the power current of A. Okay, this is a formula we all know. Current of power set of A is nothing but current of A, 2 to the power current of A. Current of power set of A equal to current 2 to the power current of A. 2 to the power current of A is alive not. Now 2 to the power alive not is C. so it means continuum, so it is uncountable. So if it natural number or set or rational number or integer, then it gives power set is uncountable. It is continuum. Okay, C means continuum, continuum, not C in this alphabet. It is continuum. Continuum means uncountable. So current power set is 2 to the alpha naught, 2 to the alpha naught is C means continuum, so it is uncountable. So from here you get power set A, this set will be uncountable if A is N or Q or Z. So for some A you get power set uncountable, so this option is also correct. Okay, so hope you understand. Are you getting a point or not? Okay, so option 4 is also correct. So in this question correct option will be option 2, 3 and 4. 2, 3 and 4. Okay, this is correct option. Okay. So hope you enjoy this session. Okay, so we are going to the last question of this session, and after that we will close this session. Okay, and tomorrow we will come another more 5 question or 10 question. Okay, and we will discuss briefly. Okay, so please watching my channel regularly, we will get everything here. Okay, so see, this is the last question. He's saying which is the following set is countable. Okay, so this is a part B type question. Okay, and I think this question came on December 2019. Okay, they're asking which is the following function from Q, which is the following are countable. Okay, so it's saying several function from Q to Q means this those set mapping from Q to rational number to rational number. Okay, is cardinality. Asking it cardinality. What is cardinality? Now we all know the several function from A to B. If it A, if it B, then cardinality will be nothing but cardinality B per cardinality A. This is formula I have written in the previous class. Okay, so cardinality B means cardinality of Q and cardinality of Q. Cardinality is alif naught and it's alif naught. Now alif naught is alif naught per alif naught. There is an important formula of cardinality I am writing here. Okay, see, alpha be cardinality and beta is also cardinality. Now alpha is equal to B, then beta. This implies alpha to the beta equal to 2 to the power beta. Okay, where alpha beta are cardinality of a set. Suppose is the cardinality of cardinality set A and the cardinality of set B. Okay, then alpha to the beta will be equal to 2 to the beta. From this here you can write this cardinality alif naught per alif naught is equal, so it will be 2 to the alif naught. 2 to the alif naught will be continuum. We all know. Okay, so this will be continuum. So you can say this will be C. Continuum is uncountable. Okay, so several function from Q to Q is uncountable. Okay, so not countable. So option 1 is incorrect. So you can say option 1 is incorrect. Now option 2, several function from Q to 0 on. Option 2. Okay, what is option 2? Several function. It asking several function. Those map from Q to 2 point set 0 on. Okay, so it cardinality. So here A is this and B is this. So what is this cardinality? So cardinality is B, cardinality B, for cardinality same formula. So cardinality will be B cardinality of 2 means 2, it contains 2 elements, and it contains Q, cardinality of Q. Every countable set is cardinality alif naught. Since Q is countable, so cardinality will be alif naught. And 2 to the alif naught is C means continuum, so this is uncountable. So this set is also uncountable. Okay, so this is incorrect because we are searching for the card set this not countable, so it is uncountable, so it is also incorrect. Now go to the last option D, setable subset of n. Okay, setable subset of n I am writing here, not going there. Setable subset of n means subset of n is nothing but power set of n. Okay, we all know the formula cardinality of power set of A will be 2 to the power cardinality of A, right? 2 to the power cardinality of A. Now cardinality of natural number will be alif naught. Now is 2 to the alif naught and 2 to the alif naught will C means continuum. So this is also uncountable. So this option also correct. So remain option 3 will be correct. So, okay. So this in this question option 3 will be correct answer. It says that what it says? It says setable function Q to 0 on which varies outside a finite set. This is a correct one. It is countable set. Okay. So you can verify it easily. See, I am going to verify this. Okay. It says that option 3. It says is the set of all function, okay, from Q to 0 on which vary several function. If it several function Q to 0 on, that is obviously uncountable. Okay, but it not restricted in this. It also there is a restriction. Several function for Q to 0 on, but this function is vanish will be identically equal to 0 on a you can say this is identically equal to 0 outside a finite set. Okay, outside a finite set. So you can say suppose I'm naming the set A, that final set will be A. So naming it like this x1 x2 xn. Okay, so you can say and the final set this, where x set this f will be 0. So you can say fx will be 0 for all x does not belongs to A, and x belongs to rational number. Okay, because x will be belongs to domain na, so x belongs to domain. So if x will be equal to 0 for x belongs to A, x does not belongs to A, x belongs to Q, means if x will be 0 outside a finite set. Okay, so if this happen, see if this happen, then you can say outside a finite set will be 0. Okay, means images of, you can say f will be like this, fx will be like this, it is 0 if x belongs to A, x belongs to A. Okay, outside a finite set, and if it's non-zero if x belongs to A. Okay, so you can say, but and it is also a finite set, x1 x2 x element will be x1 x2 xn. So in this element f has non-zero image. Okay, so you can say this element f has non-zero image, so you can say f of x1 will be non-zero. Okay, f of x2 will be non-zero, f of xn this will be non-zero. Okay, this is non-zero, and back and all other set this element f has zero images. Okay, so you can say images of f is countable na, images of is countable. You can say image of f will be countable. You can say image of countable, right? Hope you understand, because it contains only n element images. Okay, and x set other element has zero images. Okay, x set other element has zero images. So image of f will be countable. So such a f will be countable always, because images will be like the form, you can say if x1, since x1 is to, since domain is rational na, since if domain is rational, if it is rational to 0 1, so you can element of the domain can be rationalized. You can say enumerate, you can enumerate this element of the set. Okay, so I am writing the form like this, images if x1 image, so you can write like this, if x1 if x2 if xn, so on, and these elements are non-zero. Okay, and other element are 0, other element are also all 0. Okay, this element are image of f. Okay, this element image, say f of xn with a sequence. Okay, enable continuity. So these element are non-zero, so I have written there are all are 0. So such a way if you write, and then you clearly understand that this element making f to be countable. Okay, this element making f to be image of f, this element making image of f to be countable. Okay, image of f to be countable. So you can say if you take union of this f, such a f, okay, those belongs to the set. Even if name the set, what the set is the given set. Okay, suppose the name the given set is S, where S is the set given if such that a belongs to rational number to 0 1, those finishing outside 0 is 0 outside a finite set x1 to xn, x1 to xn. Okay, so such a it is countable, so countable element set is also countable na, so this gives a countable set, this gives a countable set. Okay, so setable function finishing function q to 0 1 finishing outside a finite set will be countable set. Okay, so this, hope you understand my solution. Okay, so this goes correct will be option 3. Okay, so hope you understand my solution. We have, in this video we have discussed 4 questions from part B and 1 question from part C. Okay, in upcoming videos I will hopefully discuss question of NVHM. Okay, there, because there are CSIRNET question of some question remain, we'll take this question, and after that we'll question of NVHM and TFI also. That question came in, this question come from countability. Okay, we are going to discuss each question of each exam, competitive exam. Okay, that will be asked chapter wise. Okay, so don't worry, we'll have a new video in tomorrow. Okay, so hope you enjoy my session, and please subscribe my channel. Okay, okay, so thanks for watching, and please follow my channel regularly. Okay, so you will get everything here. Okay, so don't worry. Thank you.